to another video, guys. This is about coordinate geometry, and I would like to show you how to find quickly and efficiently area of any compound shape. I will demonstrate using quadrilateral. So here is the problem. Let's have a look. Pause the video, try to do by your own, and let's have a look at my explanation. So what I advise you to do. So first of all, I advise you to put the rectangle around your shape, no matter how complicated is that. So it might be really compound, but using the boundary points, the vertices, you can actually set up the rectangle in the way I can show you. So from B to x coordinate of A, then it goes down, then it goes down again, right? And actually from point B to point C, we have the vertical line segment. Okay, right now we have a look there, and we want to put artificial maybe coordinates of that if you like, but it's not necessarily. So you can use coordinates of your original points and work with that. Okay, how to calculate the area of the quadrilateral which is inside rectangle, using the principle of superposition. So what I mean, in this case, area of the quadrilateral ABCD, so ABCD is going to be the area of the rectangle. So I just put the rectangle, and we take away the first area of the first triangle. So this is the first triangle. So any triangle that you can see here is a right angle. So we need to take away areas of all those three triangles. So that's why it's going to be minus area of triangle 1, minus area of triangle 2, and minus area of triangle 3. So this is the way how we can reach the area of quadrilateral. And right angled triangle is the best way because you can immediately find areas by using the formula for the area of triangle. So area for any triangle is 1/2 height times the base. So that's why you just need to set up the right bases and heights for each triangle. Okay, let's start from triangle 1. It's right there. And let's assume that height is from point A to that bottom point. Let it be point F. So height, let's have a look at the coordinates. So it has a level 4 to 0. So that's why definitely the height is 4. Okay, so what about the base? Base is right there. I just show you quick on this first triangle, and then we do in a similar way. So that's definitely the distance from the x-coordinate of point A up to 0, right? Up to the point D. So what we're going to do, how to find distance FD right now. So triangle 1, distance FD is simply the difference between coordinates F and D, but F has the coordinates -6, so this is -6. So D has the coordinates 2, okay? So that's why the difference is 2, let's say -6, 2 minus -6. That's how we normally find the distance between 2 points that are horizontally, okay? It's going to be just simple subtraction. That's why you're not supposed to apply complicated formula for the distance. So that's the way how you can do that, okay? It's going to be 8. So that's why now we know the base is 8 and the height is 4. So that's why area of triangle 1 is simply 1/2 times. So height is 4 and times the base 8, okay? 4 and 2 cancel, is going to be 2. 2 times 8 is 16. So we established the area for triangle 1, okay? Let's find area of the triangle 2. Let's go to small triangle 2, okay? We need to find a distance from point D, let's say to point N. So this is point N. So distance from D to N, dN distance, is gonna be the difference between the two coordinates of point D and the x coordinate of point B. So x coordinate is 9, so this is 9, okay? So 9 minus 2 is going to be 7. So this is simply 7. So this distance is 7. What about height? It's from the level of 0, right, up to the level of 1. So y coordinates is 1. So that's why this distance CN is going to be 1, okay? So that's why CN is the height is 1. Using the formula 1 over 2, we multiply them and we'll get 3.5. Okay, that's the area in units, of course. So find the area in units. You're not mentioned like any lenses. So that's why we're looking areas and expressed in terms of units or cells, let's say quadratic cells. So area for the triangle 3. Again, we have a look at the height from A to, let's say, to the point M. Okay, AM, in this case, AM is going to be from level of point A, which is at the level 4, up to B has the coordinates y equals 8. So that's what, up to 8. So from 4 to 8, there's going to be 4 units. 4 units straight away. Okay, next one. The base is from simply A coordinate for x coordinate for A is going to be -6, up to x coordinate of B. So let's just mark distance MB as the base is going to be 9. That's x coordinate of B. It's right there. And we take away -6. That's x coordinate for A. So simply we're trying to measure that distance right now. Okay, and we work it out and we're saying that this is 15. So we multiply 1 over 2 times 1 over 2 times 4 and times 15. That's why final we'll get 30. Okay, let's highlight the numbers that we've got. 16 triangle 1, 3.5 triangle 2, and 30 triangle 3. So that's why the area for the ABCD is going to be equal area of the rectangle right now. Okay, so area of rectangle is from 0 level to 8. So that's why it's definitely 8. So this distance or this side is going to be a length of 8. So 8 times, okay, MB we recently calculated as 15. And from that we take away, actually we can put a brackets and say they're pluses, so we simply need to add all 3 areas of the triangle. It's going to be 30, 16, and 3.5. That's going to be 46 and 49.5. So 49.5. Now let's calculate. So 8 times 15 is going to be 120, and we take away 49.5. We've got 70.5. So 70.5. So this is the way how you can easily work out the area of the quadrilateral using the method I show you by circumscribing the rectangle. Okay, so your quadrilateral should be completely inside or inscribed in the rectangle. Using the rectangle, you'll come to right angle triangles, and finally you can work out the area. Okay, so area finally of quadrilateral is going to be equal to 70.5 square units. So no matter, depending on what you actually use or what you're given. So that's it for now. So please like that, subscribe if you're new here, and see you next time. That was Daniel Dallas.